I'm not a researcher in the field of neuroscience. What am I? I think I'm just a student. I'm a student in the field of neuroscience. So, like all of us, we are students, and we are colleagues, probably batchmates or students in the same class, trying to pursue and learn more about this wonderful world of neuroscience. So, the human brain is the most enigmatic organ of the human body, and this has not been tapped yet. A very small percentage of has been tapped or understood, and especially the application of neuroscience in the field of L&D is even lesser. It's a very recent development where scientists have really started looking into diving deeper into neuroscience to understand what it is and then how it impacts learning. So the objective of this presentation, before we start the discussion, the dialogue, basically is to kind of set the context and then kind of share a few basic information and then give an overview of what this topic is all about. And then probably we'll get into a discussion. So, I'm sure many of you know this, but just a quick recap of how does the human brain learn. The human brain has billions of brain cells. They're called neurons. And most of us are born with about 100 billion neurons. And the neurons, they start growing dendrites. It's some kind of fiber or fiber material which grows out of the neurons. And that happens when you listen to, engage in a conversation, when you do or practice something. So every time you're listening to something, watching something, talking to somebody, getting into an act, the neurons actually grow dendrites. Dendrites can grow only from a dendrite that is already there. So essentially, what it means that any learning that can happen is basis what we already know. So it's always about what I know, and then we can build learning on top of it. Like twigs on a tree, dendrites can grow only from a twig or branch that's already there. Then like the branches growing on a tree, learning is constructed higher and higher and higher. So as we keep learning, as we keep listening, keep watching, keep practicing, keep doing things, so more the dendrites become thicker and thicker and thicker. And then they grow, like the branches keep growing higher and higher, the dendrites keep growing higher and higher, and then we build new learning. So the two dendrites kind of grow, and then they come in contact, close contact with each other. A contact point is formed. And that contact point is like a small gap, and that's called synapse. So it's called synapse, and messages are sent from one neuron to another neuron through the synapses. So the messages are passed on in the form of electric signals, and these signals actually pass through the synapses. So basically this essentially shows how the neural paths are formed when we actually learn something new, or we attempt to learn something new. So these electrical signals travel across synapses. As we learn, specific dendrites grow from specific neurons, and they communicate and they connect at specific synapses to create large and complex neural networks. So that's how we form our memory. That's how we form a new skill. That's how we form a new, we build new knowledge. We pick up a new competency. We pick up a new habit, because that's how we form habits, and knowledge, activity, they become part of us. And then there are things that we can start doing even in our subconscious, unconscious state. When a habit becomes part of ourselves, we can do it in our sleep. So that's how powerful this is. So essentially at the core of learning is change. So every time we are trying to learn something new, essentially it means that the learning changes the physical structure of the brain, and it leads to it's organization and reorganization. So just imagine millions of times our brain goes through reorganization as we build new knowledge, as we continue to enhance our knowledge. So essentially each neuron that we have could have about 10,000 plus networks. We said there are billions of neurons, and if each neuron could have about 10,000 plus networks, so there's neural networks. So the amount of learning that we gain over a period of time, and then the way we organize this organ of our body is humongous. So this picture talks about different parts of our brain. Starts with the spinal cord, the cerebellum, then we have the frontal lobe, and the left hemisphere and the right hemisphere, the temporal lobe. This is the brain stem, which is connected with the spinal cord, and all the information from the different parts of our body, different body organs, actually reach the brain through the stem. But I'm not really interested in spending a lot of time talking about the theory, which you can always read and then understand. But I will try and spend more time talking about application. But before we go that, this is a quick checklist of different parts of the brain and then what it does. Okay? And all of us know, because we are facilitators, we're trainers, we know about the cerebellum, we know about the amygdala, which is very popular, which controls emotions. We all of us learned about the amygdala hijack. And so as trainers and facilitators, we are familiar with many of this. And again, our temporal lobe, the frontal lobe, and then different other, so the hippocampus, different other parts of the brain, which actually performs different functions. But now let's come to the learning aspect. How does the brain, what is a learning cycle? How does the brain learn? We talked about the neurons, we talked about the dendrites. So basically the learning cycle has 4 activities. It starts with gathering. So the sensory cortices of the brain, they are the ones which actually gather information from the external world through the senses, by hearing, by watching, through the experience of touch, smell, and so on. So that we have, all of us know that we have 5 senses. So using different senses, the brain gathers information. So that's the start point. Once the brain gathers information, what does it do? It doesn't stop there. It's just the beginning. So after it gathers information, the temporal lobe, this is where reflection happens. So the brain reflects. What did I learn? What did the speaker speak to me? What did my friend tell me? What did I watch there? What did I read? So then you start reflecting. Do I agree? Do I disagree? Did I follow what he said? Do I do this myself? This is reflection. Then the learning process continues. After reflection, at the prefrontal cortex, that's where the creation happens. So once you have gathered information, reflected enough, now it's time to create your own hypothesis, to create your own ideas, to create your own theories, to create your own concepts that you will go back to the real world and then test it. So then you'll take it to the real world and then test it. So this is what the learning cycle is all about. Let's talk a little bit more about each of these. So gathering is through all the senses that we have. And once we gather, we go to the next phase, which is reflection. So reflection is necessary for insight formulation. So that's why we have aha moments. So when we reflect, and then sometimes we have the aha moment. Insights fuel creativity and innovation that are prerequisite for success in today's competitive market. So what's important is when we gather information, we need to step back and then reflect. So I don't know if some of you have watched this video, if it was shared. I shared an example about Nadal, who was one of the finest tennis players in the history, and but if you go back and ask his coach in the school, he would say, I wouldn't have picked him up in the first instance. He was not the most talented, most promising tennis player in his school. I picked a 5, he was not in the 5. One boy backed out, so this guy got an opportunity to sneak in, and he sneaked in. And how he became a world-class player, I don't know. So when they interviewed Nadal and asked him, what's the secret of your success? He said, in between the shots that I play, I reflect. Sometimes the referees have even penalized me. They have imposed penalty for me for me to take too much of time to kind of do my serves. So he says, in between my serves, I just stay back, I keep bouncing the ball, and I take a lot of time to serve the next ball because I am reflecting. What went well in the last one? What did not go well? What mistake I made? What can I do differently this time? So great example of reflection. Let's go back to our corporate business world. The business leaders tell us, train people. So we say, okay, let's have some time for reflection. Well, where is the time? We have to put tick marks on training programs. So there's no time for reflection. Just give them overload of information. Okay, but there's no time for reflection. But reflection is an extremely important part of the learning process, and we as L&D practitioners will have to ensure that we create room for it. We need to create room for it. And just now Major was saying that we will finish this exercise, we'll have an activity. And we said, depending on time. So reflection is always my apologies.
I'm having it. Wrong side. The pen for her. Yeah. I'm changing my seat.
Let's go back to questions. I didn't know you.
So let's move on, and then let's talk about the next activity, which is creation. Because it's not enough to reflect, we also have to create. That's why the learner shifts from receiving and absorbing information to creating knowledge in the form of abstractions, such as ideas, action plans, concepts, theories, methodologies that you can then take it to the real world. So that's where creation becomes extremely important, and the learner is actively engaged in doing that. He or she creates his own theories, own action plan. It's not imposed on him or her. So that's a very important activity that we need to understand and create opportunities for that. And the last one is testing. This is like taking that hypothesis, that concept, that abstraction, testing it out. Active testing allows the brain to make the abstract concrete by transforming mental ideas into physical events, into real actions, into real programs, into real experiments, and then test it out and then see for yourself it is working, not working. And that's where learning is complete. Because that's when you go back, you reprocess, you reflect again when you're testing if something is going right, not going right, did I understand this right, did not understand this right, do I need to go back and then change my action plan, do I need to go back and then change the abstractions, and so on. So this is the most important part of the learning cycle. And that's how the brain learns. So to increase learning effectiveness, learning solutions should allow for gathering, reflection, creation, and active tasting within the learning process itself. So as facilitators, as trainers, as L&D practitioners, as training leaders in organizations, our role is to ensure that we make sure that people go through all the four when we are conceptualizing, planning, and implementing or deploying learning solutions. The power and duration of learning is proportionate to how many regions of the brain are engaged. So we saw that the different parts of the brain are engaged in the process of gathering, reflection, and creation and testing. So how many regions of the brain are engaged? The completion of the entire cycle is required for true change in behavior and performance. The true change in behavior and performance happens only when we gather and reflect and then create and then do it ourselves. And then when you start doing it with conviction, again and again, then there is change in behavior, change in performance, change in the formation of new habits. Essentially what happens that you see the character of the person goes through transformation. So that's the powerful learning process. So how do we make this happen? This is what Albert Einstein, the famous scientist, I mean, if he says something like this, then who are we? He says, I never teach my students. I only attempt to provide the conditions in which they can learn. So that's what Albert Einstein says. We as trainers, we never train. We as teachers, we never teach. All we need to do is we need to create conditions. Because you saw in the learning process, it's the human brain which does everything. It gathers, it reflects, it creates, and it does the testing. So all we need to do is create the right conditions where the brain can start functioning. So what are these conditions? As L&D practitioners, create a non-threatening environment. Okay? So this is a compliment to you for creating this non-threatening environment where everybody can learn through collaboration, through interaction. There is no fear of losing out to anyone. There's no fear of being in a competition and then being ranked. Fun and friendly atmosphere. So learning happens the maximum when we create positive emotions. So when there is a fun-filled environment, when there is a positive environment, when there is a reward for a recognition for good performance, there's very positive feedback. There is genuine support and empathy for somebody who is struggling to learn something. So when you have an environment like this, a fun and friendly atmosphere, opportunity for collaboration, when you avoid multitasking, Major Varga talked about multitasking. It's very important. The millennials today take pride in the fact that they can multitask very well. My sincere advice would be, well, my learning out of this little research into this subject, the brain is not wired for multitasking. It can't. Of course, you can. I mean, while driving, you can talk to your spouse. It's possible. While cutting vegetables in the kitchen, you can listen to music, or maybe talk to your spouse. In the kitchen, you can probably do all of this. You cannot do two high-order tasks. So you can't read a book and drive at the same time. You cannot attend a meeting and also, going through and then prepare a presentation at the same time. Because brain requires focus. It requires attention at one thing at any point in time. So we should not encourage brain kind of shifting from one thing to another thing to another at the same time. Well, but at the same time, multitasking is also important. But there is something called good multitasking, something called bad multitasking. So bad is that I'm driving and then talking on the cell phone. Bad multitasking. We should not do that. That's risky. But good is, well, I'm driving, but I get a call, I stop. I take the call, and then I move on. So I'm still multitasking, but I'm focusing on one task at a time, while I'm still performing multiple things. The learning setting, make it closer to reality. Teaching empathy, bring dogs, make it as real as you can. So that's the most important thing, because as long as it is in the boardroom, just a lecture like, that's going on at this moment, that's not the best setting for learning. The best setting for learning is which is closer to reality. So nowadays, a lot of schools have started doing this. When they're teaching biology or teaching botany to students, they take the students to the garden in the school, and they actually teach them, how, they go and take the children to the school garden, and then show them the trees and the plants, and then say 70% or 80% of your lungs is inside that plant. Then explain that how, as human beings, we breathe oxygen, breathe out carbon dioxide, and then how plants do the reverse, and then thereby how our lungs are dependent on them. So if you just make people learn this by rote, or by cramming, or by hatting or memorizing, there will be no learning. So when you take the setting closer to reality, that becomes perfect setting for learning. So let's ask ourselves for a moment. Are we creating these conditions for our learners when we create a training program? Maybe we do some of this. Maybe we don't have any control over the setting and then the conditions. Do we make an attempt to do this? Yes, no, anything you would like to?
It has to be, otherwise, we're talking about adults, so there's again, unfortunately for adults, we come with a lot of experience. So to shed that, to really even take what you're talking about is the first step, and hence, I think adult facilitation definitely requires the first one, which is obvious. So we're not questioning your knowledge or your experience.
Yeah.
We are here to, like you rightly said about the Albert Einstein, that's true. Nobody here is to teach anybody to anything. Fun, I don't know, because some programs definitely, you don't need fun, you need to challenge them. You need to make them think a little more deeper. So I think you're right, depending on the program. Definitely, I think otherwise you're not facilitating, you're only training, which is more technical.
Absolutely, thank you. Very, very well said. Step on something. Okay. All right. So we talked about the conditions. What about what we as L&D practitioners? What are we expected to do to make learning effective using the principles of neuroscience? I'll quickly go through this. Engage the entire learning cycle. Make time for reflection, creation, and testing. Make a connection with the learner's prior knowledge, because a dendrite can grow on another dendrite. So new learning can be built on the prior knowledge that we have. Create opportunity for social engagement and interaction. Engage both feeling and thinking. When you do reflection, you're actually getting people to think and feel as well. So that's why reflection becomes important. Actively attend to attention, gaining, holding, and focusing the learner's attention. Engage the maximum number of senses, because we always believe it's the hearing which is the most important activity, or maybe hearing and watching, but engage other senses as well. Get them to smell something and then touch something and feel, and then get them to hear, watch, listen, read, everything at the same time. So these are things that trainers, facilitators like us are expected to do. What the learners are expected to do as learners, because while the trainers will do a few things, but as learners, as individuals who are trying to learn new things, we need to stretch our brain. Stretch our brain like any other part of the organ. We go to the gym to exercise and then to build muscles and so on. So the brain also needs to go through exercise. So challenge your brain. Take an unfamiliar route to your office. Take up a new assignment, a project that you've never done before. Don't be in your comfort zone. Only way the brain becomes sharper and then stronger is only way stretch your brain. Wear the teacher's hat. Be a teacher yourself. That's why somebody said that I remember only 10%. I hear, I read only 20%, remember 20%. I hear and read and then remember 30%. I discuss, I remember 50%. But I teach, I remember 90%. So the best way to learn is to teach. Stand up and then teach. Avoid multitasking. Sleep away to glory. So if you really want to use your brain optimally, you need enough sleep. I know my wife is smiling because she always complains that I'm not sleeping enough. And so she will tell me that you practice what you preach. So, but that's the truth. If you want to make your brain optimally operate, then we need to sleep enough. And a couple of things that we need to remember about this. The brain, while in sleep, a lot of our information, data, which is in our short-term memory, all of us know that brain has both short-term and long-term memory. Short-term memory is like a RAM in your computer. It's a working memory. You keep using it and then you forget it after some time. You come from your home to this place, you would have seen many things, you would have remembered a few things, but maybe in a day or two you'll forget everything. Not everything goes to the long-term memory. What is essential and important, that goes in. So in sleep, actually the brain is also active. So brain is not inactive when we're sleeping. A lot of information and data, a lot of our motor activities and tasks that we have learned, they actually move from short-term memory to long-term memory, and many of these tasks become automatic. If you don't allow brain, if you don't sleep enough, then we might lose out on that opportunity. So the muscle memory that the brain is building, or the automatic habits that we are building, we might lose out on that. That's why scientists have said that people who do not sleep enough may have a memory problem. They might forget things. And also a lot of decision making happens while in sleep. And Einstein has said, a lot of my creativity, my innovation has happened in my sleep. I got up from my sleep and then I had a wonderful idea. So that just did not happen in a fraction of a second. That creation, that innovation happened when I was asleep. So brain is extremely active when we are sleeping. So allow your brain to sleep yourself so that your brain can do a few activities which normally brain cannot perform when you are awake. Meditate. Meditation is a powerful way to make our brain cells active, sensitive, and perceptive. So a lot of these things, so meditation is all about concentration. So when you're concentrating on something, it's like you have a lens and then you focus the sunlight on a piece of paper. On one point you focus for several minutes and then you see that the paper starts burning. So it says the power of concentration. The sunlight really cannot burn anything. But when we focus that on a particular point, we see that that the paper starts burning. So similarly, when we focus our brain on a particular point through meditation, then that creates a lot of energy, and then our brain cells become more active, they become more perceptive, they become more sensitive. So complex mathematical problems, or problems in physics or science or business, what I could not understand for many months and weeks together, suddenly I will realize I'm able to comprehend and grasp them, because your brain cells become more active. The ability to perceive becomes stronger. So meditation is a very important, powerful tool to kind of make your brain powerful. So this discussion can go on and on, but I just want to give you a quick overview before we actually engage in a dialogue. So I would stop here and then back to you.
Thank you, Surya. That's a wonderful narration. But